All right, so this is going to be the first systems portion of the 7.5 differences. Um, I had said in the introduction portion of this, we were going to talk about the things that are only different between the 7.5 and the 7.6. So, this is not going to be a deep dive into these systems on these aircraft. This is simply going to be the differences for the 7.5. If you want to deep dive into these systems, you can go to this playlist right here. It's the 7.6. You can go watch the video there, and then here we'll give you the differences for the 7.5. So if you're coming here for 7.5 specific uh, systems information, I don't have it for you. I'm sorry. I'm only going to do the differences. So, with that being said, the first thing we're going to start with is going to be on the right side of the overhead panel, and that's going to be our air systems. So, the air systems is going to include the bleed air system, the air conditioning system, the what's it called? The equipment cooling system, and pressurization is not included in this because there is no difference in pressurization between the 7.5 and the 7.6. How the system works and everything like that, it's all the same. So we're going to forego that. Now, again, I am using a PowerPoint presentation to go through this, and I know that most of you hate PowerPoint, but I'm sorry, this is the easiest and best way for me to be able to get through this information and to be able to make it somewhat coherent so you can understand it, or at least that it makes sense from what I'm saying to what you're seeing. So, again, we're starting with the 757 air system differences. So, this is basically everything that matters on the right panel of your overhead. So, you got your right panel and then a little bit on the second to last panel there on the right. Um, and we'll go through each one here, and I'll kind of explain some of the differences as we go through. So this first one, bleed air. The bleed air system works very similarly to the 7.6. However, I'm sure that if you look at this panel, you can see that there are some differences that aren't there in this particular case. So, first thing that we can see is we only have one isolation valve on the 7.5. We don't have three like we do on the 7.6. The 7.6 has a left and right isolation and a center isolation. Okay, so they're all labeled for where they're located. This particular valve is only located, or it's only named for what it is, which is an isolation valve, because there's no need to differentiate because it's the only one. As you can see, you've got duck, bleed, and high stage lights, just like you do on the 7.6. Now, on the 7.6, you may see an RSVR light. Same thing on the 7.5. I'm not an RSVR. Sorry, I'm talking two different systems. In this particular case, I have duct leak, bleed, and high stage. I could have a duct leak, bleed, and overheat on the 7.6, so that high stage goes away on the 7.6. Now, this is where I honestly think Boeing engineers, and if you work for Boeing or know anybody that works for Boeing, you can verify this for me. That'd be great. But I honestly think they had two sets of engineers who didn't like each other and wanted to just piss pilots off. That's all they wanted to do. And the reason I say that, so if we look at these lights, right? I've got a duct leak light right here. The duct leak light is the same whether it's on the 7.6 or 7.5. Duct leak is a duct leak is a duct leak. Okay? It means there is a leak in the duct. That's simple, right? Bleed. You remember what that was on the 7.6? It's pressure. It's over pressure. But on the 7.5, it's over temperature. So a bleed light is a high temp. On the high stage, on the 7.6, that was a temperature. On the 7.5, it is a pressure. It's telling you that you have a bleed or a high pressure valve open when it should be closed. We talk more about that with the 7.6, but if we think about this, I've got a duct leak, high temperature, high pressure on the 7.5. Okay, high temperature, high pressure. Okay, and I'm going to emphasize that because that is a big difference between the 7.5 and the 7.6. Now, the way I always remember it and the way I always teach it, and I hope that this helps you, is on the 7.5 TP, toilet paper. Makes no sense, right? On the 7.6 PT, paper towel, so pressure temperature, paper towel. 7.6 is bigger than a 7.5. A paper towel is bigger than toilet paper. It works in my head, and if it works in yours, great. If it doesn't, I'm sorry you even had to hear that last 30 seconds. But that's how I remember it. So it's pressure temperature for a 7.6, temperature pressure for the 7.5, and that's paper towel, toilet paper. Okay? Now that I've thoroughly confused the hell out of most of you, let me go on to the isolation valve. Now, the isolation valve works a little bit differently between the 7.5 and the 7.6. Notice how it doesn't have a guard on it like it does on the center for the 7.6. And that's because this one is meant to be turned off and turned on. Very similar to the left and right isolations on the 7.6. So, in this particular case, it'll be open during, pack operation, during engine start, things like that. But then, after engine start, you close it and you leave it closed unless you're directed by QRH. So that's simple enough, right? Everything else is the same. Duct pressure, gauge, yeah, it's red and PSI, great. And left engine, right engine, and APU, those are all bleed air valves, and they're either open or they're not. And the off lights and the valve lights are the same. Off lights mean that it's not working, or if it's a valve light, it comes on and goes off to tell you that it's in transit or that it's a disagreement light, right? Just like on the other airplane. So there's really no differences in that. The biggest differences here are going to be with that between that bleed and high stage lights. And if I did thoroughly confuse you with that, I do apologize, but it makes sense in my head, so I really hope it makes sense in yours. It also helps if you write it out a couple times to kind of let it sink in a little bit. But anyway, if you have any questions about the bleed air system, please let me know, and we can go from there. Next panel is going to be the one up from the bleed air. It's going to be our air conditioning. Now, again, this is another one where there's not a lot of differences when it comes to how this system works. And what I mean by that, down at the very bottom here, we got our pack controllers. I've got auto, N, C, and W, right? So I've got auto, normal, cold, and warm. Same as what I can have on a 7.6. Most of the time, you're only going to see N and W because that's just seems to be a more normal panel, is a N and a W. But if you have a C, fine. You have a C. It means you can keep it cooler in there. The lights above that are also our pack reset switches. So these lights here, in op, pack off, these are going to work the same way as they do on the 7.6. Trim air works the same. Recirc fans. Now, if you fly a passenger 7.6, there's not going to be any difference here. Okay? If you fly a cargo 7.6, you will look at the recirc fans and go, I've never seen those on the panel before because they don't exist in the 7.6. During the cargo conversion, they get removed. So there's no switches there. And if the switches are there, they're usually labeled inoperative. On the 7.5, however, on the passenger carrying 7.5s, you're going to see two recirc fans just like you do here. You'll see left and right recircs. Primarily, the recirc fan is going to be used for equipment cooling. That's essentially what it's used for. It's used for equipment cooling. Now, on the cargo 7.5s, there is a slight difference. The right recirc fan will be listed as inoperative, while the left recirc fan will continue to be operative. Again, the left recirc fan is kept in for the equipment cooling side of things. So on the 7.6, recircs don't exist. On the 7.5, only one exists in cargo. They both exist in passenger. Okay. Outside of that, the rest of this panel is the same. The inoperative lights work the same way. The off lights, everything works the same as it does in the 7.6. So the only difference here is the fact that you do have recirc fans on the 7.5. Now, again, if you fly past your 7.6s, there is no difference. If you have cargo 7.6s, there's a big difference because now I've got an additional fan in that particular area, which, by the way, is shown similar here. Now, notice I've got that green box around part of this schematic. The reason I have that is because that's the only difference in this schematic. So, on a 7.6, the ACMs between 7.6 7.5, exact same. So the air cycle machines are the exact same. The packs operate the exact same. Everything works the way that it should between the two airplanes, exactly the same. Now, the part that I have highlighted there, right? So I got a left recirc fan, a flight deck zone. The reason those are highlighted is because this line right here does not exist on the 7.6. This is a direct line from the left pack straight to the flight deck. Now, granted, on a 7.6, the left pack does operate at a higher pressure to allow air to go to the flight deck zone and try and keep smoke and stuff out of it. But on the 7.5, there is a direct line to the flight deck zone. So it is an isolated thing where the left can provide air straight to the left pack, or from the left pack to the flight deck. Left recirc fan. Remember how I said this is more for the equipment cooling aspect of things, right? Well, it also adds air into your mixed manifold. Now, granted, you're not really gonna care too much because it doesn't really do a lot in this particular section. It is meant more for the equipment cooling portion. But it does add air into the mixed manifold, so it is something that it does do. And like I said, it is an additional fan that is put into the system that does not exist in the 7.6. So again, just another small difference here in these particular air systems. Everything else, zone temperature controllers, trim air valve, the way the ACM works, all of that stuff is the exact same as the 7.6. Okay. Negative pressure relief valves. So, this is going to be a little bit different again, depending on if you have a cargo airplane or if you have a passenger carrier. If you have a passenger carrier on a 7.6, obviously you don't have the main cargo door. So, you don't have the negative pressure relief valves in that particular door because it doesn't exist. But you have negative pressure relief valves in all your lower doors. So your forward cargo, your aft cargo, they both have negative pressure relief valves in them. On the 7.5, however, even if it is a cargo carrying 7.5, you do have negative pressure relief valves on the left side of the aircraft, kind of forward of the main cargo door. So, but they're lower, obviously. Look in here, they're lower. You also notice here, that's your TAT. Your TAT is in a little bit different spot as well compared to what it was on the 7.6. 7.6, the TAT is right on the front of the nose. The TAT on the 7.5 is located on the left side of the aircraft. Now, does that have anything to do with the air systems? No, I just thought that since it was in the picture, I might as well show you. So, this really is just showing a different location for your negative pressure relief valves. That's all it is. They work the same, though. They get pulled in whenever there's a differential pressure that requires them to be pulled in. But outside of that, I mean, it's just the location. It's the difference. This is the system everybody loves to hate. And I get it. Equipment cooling systems suck. In the 7.6, it is a much more complicated system. You have a rotary switch that goes from in three different positions. You got standby, override, and then just the auto position. So you've got the three positions there. This is literally a push button. That's all you have. So you've got a smoke light, a push button here for alternate overheat, and a cabin altitude light. Now, I mentioned that the cabin or that the pressurization isn't any different. It's not. The pressurization, still at 10,000 feet. Cabin altitude, you get a cabin altitude light, so on and so forth, unless you have a high altitude switch and all that other stuff that we talked about for the 7.6. The difference here is the function of the panel. So literally, all you have is a push button. So if you're in an overheat condition or a smoke condition or anything like that, all you're able to do is push the button. It's either going to work or it isn't. I'll show you here in just a sec a little bit of what that looks like. So on the 7.6, it used what was called a skin heat exchanger or radiator, if you want to look at it that way, where if it was 45 degrees or below, the overboard exhaust stayed open and it would stay closed, and it would allow that air to kind of circulate through the system. If it got above 45 degrees, it started to dump that overboard, which is why it's called an overboard exhaust. The 7.5 works pretty much a lot different in that regard, because we're not talking about a temperature. We're not talking about a set temperature. We're talking about a differential pressure, so PSID. Okay, so in this case, we're looking at 2.8 PSID. If we're less than that, and what that is basically sitting on the ground, no engines running kind of thing. We're just running the APU for packs or whatever, and we're less than 2.8 PSID. The overboard exhaust, as you can see down here, is open, and it's allowing all that air to be dumped off. So this is ground operation, essentially. That's the easiest way to look at this. So on the ground, less than 2.8 PSID, the overboard exhaust is open. Now, you can see this is a slightly different system. You've got some smoke sensors, you got a primary fan, alternate fan, and your left recirc. Notice that the left recirc is kind of like your exhaust fan on the other side, right? It's helping pull that air through those systems, and then it's blowing it out the overboard exhaust. That's essentially what your left recirc does. You have two fans. You got your primary and your alternate fan. If you want to guess, your primary fan runs when you don't have anything pushed, when you're not in the alternate system, right? So the primary fan runs when the primary system is in control. Now, greater than 2.8 PSID. In this case, we're talking about we're getting ready to take off. We are in in-flight conditions. So or ready to be in flight conditions. So engine started, you're taxiing out, you're whatever. Your cabin starts to pressurize when you push the thrust levers up, right? So when that happens, you get above that 2.8 PSID, your overboard exhaust closes. And why does it do that? Because it's a giant hole in the bottom of the airplane. And if it doesn't close, you can't pressurize. Or you'll have a very difficult time pressurizing. Maybe if you had two ridiculously powered packs, maybe they would be able to overcome it. But, I mean, the hole's this big. I mean, you could damn near put your head through it. So I don't think it's going to be something where you're able to do that, right? Now, in this case, the air is just simply circulating through the system, right? That's all it's doing. It's just circulating through the system. Your primary fan's still the only one running. And then you've got your alternate fan, your left recirc that are still going to be running. See, even I can't stand talking about the equipment cooling stuff. All right, so now if we look here, we got smoke sense. So remember, we got those smoke sensors that are in there. And the smoke sensors basically have either a blow-by, which creates a venturi to pull that in, or there's fans that pull it in, and then it detects the smoke, and it says, oh, there's smoke, we need to do something. So what it does, it turns off all your fans, because we don't want to affect the smoke in any kind of way. We don't want to blow it around. We want it to simply just get sucked out of the airplane. Now, on the 7.6, you had what was called a smoke override valve on the left side of the airplane. 7.5 doesn't have that. The 7.5 literally only has the overboard exhaust. That's all it has. So, when smoke is sensed, it turns off all your fans, it opens up your overboard exhaust, and it starts to pull that air out via a venturi. Okay, so that differential in pressure pulls it right out of the side of the airplane. Now, granted, you're probably going to depressurize, or you're going to more than likely lose pressure in this particular case. But I would rather do that than have the smoke continue to build and all of a sudden end up in the cockpit. right? That's your options. So here, pulls it all out. Once the smoke is no longer sensed, the system can go back into a normal mode, and then once it goes back into a normal mode, then you can hopefully not have any more issues. And if you do, the cycle just continues at that point, right? Now, let's say I have an overheat. So an overheat, there's temperature sensors in through here, and when the temperature sensor gets too high, it's going, there's an overheat. So it kicks on the overheat, turns off my primary fan. Or I guess in this particular case, that's my mistake. In this particular case, primary fan has failed. That is why we have the overheat. And that's because there is no airflow being sensed, right? So when there's no airflow being sensed, you got this thing here. It's a low flow sensor going, hey, I don't have any air. It must be getting hot in there. So overheat is what it kicks on. So in this particular case, your left recirc can only do so much. It can only help pull that air through so much. But there's only one thing you can do, and I bet you guess what I'm going to tell you. Follow the QRH, right? So always follow QRH, because each company is going to have a different way of wanting to do things. And maybe, one company thinks they know better than Boeing. They want to do it this way, or blah, 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 right? So always follow your QRH. I can't go through each company's QRH. For one, I don't have access to all of them. Two, I don't want to. That's a big one. I don't want to. But in an overheat situation, here's what's going to happen. Is you're going to run your QRH. It's probably going to tell you to do something like, I don't know, hit the alternate switch. And because it's the only thing you have the ability to do, which is to push that alternate switch. Now, when that happens, the overheat indication will go away because it gets inhibited for, like 5 minutes, something like that. And when it goes away, what it's doing is it's looking for airflow, right? Very similar to what it does on the 7.6 with the smoke override valve. When the smoke override valve opens, it's trying to sense airflow going out. If it does, cool. If it doesn't, it throws you a light, and then you have problems. Same thing here. So let's say that I push the alternate switch, and the alternate fan doesn't work. So that means this thing here doesn't turn on, and it goes to crap on me. If that happens, there's not going to be any airflow. And with no airflow, the low flow sensor will kick off again and say overheat. Well, now follow your QRH, but my guess is you're going to start losing equipment because stuff's going to overheat. So just be cognizant of that. On the 7.6 side, you have about 90 minutes. I believe it's about the same on the 7.5 side for things that are necessary equipment. What the definition of necessary is, as determined by Boeing, there is a list somewhere, but there's no point in you memorizing it. Just realize that essential equipment or necessary equipment will last longer than non-essential equipment. That's a good way to remember it. Now, the last thing that really has to do with your equipment cooling system is when you get into your fire indications. So when you get into a main cargo fire, let's say on a cargo carrying airplane. If you're a passenger carrying airplane, you got flight attendants. They can go back and they can put out a fire with a fire extinguisher. Granted, everybody's got to be on oxygen. There's a whole bunch of other stuff that comes along with that, but you have somebody there that can fight the fire. On the 7.5s in the main deck, there is no fire suppression, just like on the 7.6s. However, the panel is going to look a little bit different. If you look at that and you go, it doesn't look like the one on the 7.6. Well, duh. That's because it's not, right? So if we look at this, we've got some lights, got a main fire light, we've got lights down here on the airflow valve switch, and then valve closed forward and aft. So when I get a main deck cargo fire, I'm going to follow my QRH. In there, it's going to tell me to push this button for the airflow valves. I'm going to push that button, and it's going to say close. And then when it says closed, I'm going to get valve closed, valve closed. Simple enough. Now what's going to end up happening is it's going to turn off, it's going to turn off my packs. It's going to put one pack in the low flow, and some other things are going to occur. There's a list that you should find in your FCOM. And again, it's all going to depend on your company on whether this stuff is listed or not. But there's going to be a list of stuff that switch does. And when it does those things, you know that those things are done by these lights. So if the valves show closed, if the switch says closed, everything has occurred the way that it's supposed to happen. both of your fans are going to be turned off, or all three of your fans, I should say. Your aux, or your alternate, your primary, and your left recirc. They're all going to be turned off. And they're going to allow that air to go out the overboard exhaust again, very similar to if you have a smoke indication. Okay? It's the same situation. What we're trying to do is slowly depressurize the aircraft. And as we slowly depressurize the aircraft, we're hoping to fight the fire because we're taking the oxygen away from it. Now, we could argue all day on whether or not it's a good idea to continue to try and fight the fire, or if you just need to get on the ground. That's a total crew decision. That is not anything that can be taught in my mind. There is no actual hard number where it's like, if this happens, land immediately. It's just not that way. When you're put in these positions, when you're a captain and an FO that's in a situation where you have a cargo fire, you guys have to be the one that make the decision of whether or not you're going to land as soon as possible, as soon as practical, whatever you want to say, or if you're going to try and fight the fire as you're trying to get to your destination. All of that's totally up to you. All I can tell you is that's how the system works, and I would probably try and get on the ground, but that's just me. All right. Now, cargo heat. Very important if you're carrying, animals or something on the underside of the aircraft. United, at one point, I believe, had issues. I think it was United. There was some major airline that had issues that were carrying animals underneath there for their passengers, and when they got to where they were going, they didn't have the heat on, and cold temperatures down into negative 50 don't do so well with animals. So you end up having pupsicles, as bad as it sounds. Now, looking here in the aft cargo compartment for your cargo heat, there is a little electric heater. Basically, it is a wire that has electrical current running through it that heats up, and then there is a fan that blows across it and blows that heat into the aft cargo compartment. And then that air just kind of gets circulated back there that way. Because that is where the animals are usually carried, is in the aft cargo compartment. If you have a passenger carrying airplane, you have animals that are getting put into the lower deck, they're usually put into the aft cargo compartment simply because of this electric heater. The forward cargo compartment does receive some heat, but it is kind of a residual from what's in the main deck. So it's kind of a residual from what's up above. Because that air gets pulled in into the forward cargo compartment, and it allows you to have a little bit warmer air down there, but not like you would in the aft cargo compartment. Then the final thing here for the air systems is you do have a limitation with the 757. If it's been on the ground and it's electrically powered for more than 20 minutes, depending on the temperature outside, depends on what you have to do to it. And this is simply because of the electronics on board, right? So if we look here, 94 to 105 degrees Fahrenheit, you can do the conversion to Celsius. I'm sorry, I don't have it up there. And I use Fahrenheit. So 94 to 105 degrees Fahrenheit. So that's hot enough in its own, right? Just that's hotter than I care to be on an airplane. You have to have at least a crew entry door or one AC pack or the equivalent ground cooling cart operating in this particular instance, right? So if I need an AC pack running on the ground, I got to have my APU on. That'll give me a pack on the ground. Or I could just have the ground cart hooked up and giving me air that way. Now, if it's 106 to 120, crew entry door is no longer effective. So that door doesn't matter if it's open or closed. I have to have at least one AC pack or equivalent ground cooling attached to the aircraft in those particular temperatures. Again, 106 to 120 is a place where I don't care to be. I've been where it's 130 outside. I don't like it. I don't want it. Keep it. But obviously, with traveling the world in these aircraft, with what the capabilities and that kind of stuff are, you may end up somewhere like that. Above 120, I'm going back to the hotel. That's just me. I go out. Yep, 120. Nope, I'm done. I'm calling fatigue. It's over. But if you have to operate with a greater than 120 degrees Fahrenheit, if you're electrically powered on the ground for 20 minutes or more, you are required to have 2 AC packs running on the ground or equivalent ground cooling. And what that does is that allows enough air to go through your equipment cooling section to be able to cool things to where they won't overheat and won't break. Okay? Now, this is all if you're electrically powered for more than 20 minutes on the ground. Not just if you're landing somewhere, dropping something off and then taking off again. I'm trying to think of when that would occur. Like 99% of the time, you're probably going to be on the ground, electrically powered more than 20 minutes, unless you're one of these crazy freaking regionals that have like 22-minute turn times, which is nuts to me. But on a 7.5, I mean, when you're a cargo side anyway, you got a 45-minute download, 45-minute upload. I mean, you're on the ground an hour and a half with it being electrically powered. This may come into some sort of concern, right? So, on that note, that's really all the differences there are when it comes to the air systems on a 757 versus a 767. Again, please, questions, ask them in the comments. Send me an email. Send me whatever. You join the Facebook group and send me a thing on there. Anything you can do to ask the questions. I love answering questions. I love learning stuff. So if it's something I've never seen before, I'm more than happy to look into it. The next videos I'm going to talk about the differences a little bit in the hydraulic system. We'll talk a little bit about the fuel system. And really, I mean, there's not a lot of differences between the 7.5s and 7.6s, but we'll get through it, and hopefully it'll help you guys be prepared just a little bit more for either a type rating, or maybe you're adding 7.5s to your fleet. Maybe you're going to be one of the ones that's starting to fly the 7.5s, and that'll be cool. So anyway, as always, shameless plug: like, share, subscribe. Whatever you got to do, send it on Facebook, send it on YouTube, send a text message. I don't care. Get it to people who need to know it. And, yeah, just, I got nothing else. I always have, I always screw this up at the end of it. It's like, share, subscribe, and then I'm pretty much done. All right. You guys have a good one. I'll see you in the next video. Bye.